With the rapid development of drone technology, high-altitude and long-endurance strategic unmanned reconnaissance drones have become the core equipment for modern battlefield situational awareness. With its unique, high-altitude flight capability, China's self-developed WZ-7 has not only redefined the tactical boundaries of reconnaissance drones, but also built an impenetrable cloud barrier. With its technological advantages, the UAV, which can fly up to 20,000 meters high, has achieved all-weather control of the complex battlefield environment by placing itself in the blind zone of traditional air defense firepower, while the technical logic and strategic wisdom behind it have become the focus of modern military science and technology competition. The height advantage of the aircraft is essentially the ultimate use of the physical characteristics of the atmosphere. At 20,000 meters high altitude, the air density is only 7% of sea level. The thin atmosphere makes the traditional anti-aircraft missile maneuverability decline precipitously. The missile control rudder is difficult to adjust. The flight trajectory through the aerodynamic effect of the power system is also due to the oxygen content of the oxygen content has been reduced and the efficiency of the sharp decline. This natural barrier allows the WZ-7 to cruise freely at the edge of the theoretical altitude of most active air defense systems. Japan's Ministry of Defense 2023 annual report shows that its main air defense missile 03 type medium-range surface-to-air missiles, the maximum altitude of only 15,000 meters, which means that even if the trail of non-detective -7 found that conventional means of interception is also difficult to reach this in the stratosphere cruising in the high altitude I. More strategically, this altitude advantage is not solely dependent on the physical properties of the flight platform. The diamond-shaped wing aerodynamic layout of the non-detective 7, through the coupling of the front wing and the main wing, in reducing the induced drag at the same time significantly improve the lift coefficient, which makes it in the thin atmosphere, can still maintain excellent handling stability. Combined with the continuous thrust output of the domestic high-power turbofan engine, the UAV is able to achieve uninterrupted cruising for more than 24 hours at an altitude of 20,000 meters, forming a persistent monitoring capability for key areas. Against the threat of high-altitude drones, laser weapons were once seen as a potential game changer. However, the flight altitude and atmospheric characteristics of the non-detecting 7 precisely hit the technical weakness of the laser weapon system. Laser beam in the atmospheric transmission process, water vapor molecules, aerosol particles and even natural haze will trigger serious energy attenuation. Measured data show that a typical tactical laser, with a wavelength of 1064 nanometers, will decay to less than 30% of its initial value after 10 kilometers of transmission in a humid environment. To achieve effective destruction of a large UAV such as the undetected 7, it is necessary to maintain a kilowatt-level energy focus on the surface of its airframe for at least 15 seconds. This is still theoretically possible in the dry stratosphere, at an altitude of 20,000 meters, but the actual probability of a kill tends to be close to zero under the complex meteorological conditions common to the monsoon region of East Asia. Japan's Defense Equipment Agency in 2021 announced the High-Energy Laser Air Defense System test report confirms this predicament. Its test-type 30 kW laser on the 5,000-meter altitude radar cross-sectional area of 0.1 square meters of the target aircraft destruction success rate of only 17%, and when the target aircraft to 10,000-meter altitude, the system has completely lost operational effectiveness. This exposes the multiple technical bottlenecks of laser weapons in terms of power density, atmospheric compensation algorithms, beam control precision. In sharp contrast, China's self-developed distributed optoelectronic countermeasures system has achieved modular deployment and can further reduce the probability of being locked by laser weapons through the coordinated operation of multispectrum jamming bombs and directional energy protection devices. When technical means of interception fail, direct confrontation by air power becomes the last option. However, the dispatch of manned fighters to intercept high-altitude drones is turning into an unequal war of attrition. The average service life of the Japan Air Self-Defense Forces F-15J fleet has exceeded 35 years, and the problem of structural fatigue in the airframe is becoming increasingly prominent. According to a special study in the journal Aeromechanics, a fighter jet performing an emergency climb to 20,000 meters for an intercept mission will cause wear and tear on the airframe bearing structure equivalent to 10 routine training flights. This tactic of fighting drones with manned aircraft is rapidly depleting the remaining lifespan of the aging fleet as the frequency of the WZ-7's missions continues to increase. Ironically, the non-contact nature of modern high-altitude reconnaissance aircraft makes interceptions often symbolic. Equipped with synthetic aperture radar, SAR, and electro-optical reconnaissance systems, the ND-7 can conduct high-precision imaging reconnaissance from hundreds of kilometers away, allowing the aircraft to carry out its mission without entering the airspace of another country. By the time the F-15Js have completed their emergency liftoff and accompanying flights at a cost of millions of dollars, the target drone may have already completed its intelligence gathering and returned to the airspace. This strategic level of efficiency gap, so that the traditional air interdiction more and more like a costly show. The real value of the WZ-7 lies in its system integration capability as an information-based combat node. Through the high-speed data chain and Baidu satellite navigation system seamless connection, the aircraft will be able to obtain real-time multispectral reconnaissance data, synchronous transmission to the ground command center, early warning aircraft group, and even frontline combat units. The construction of this detection control fighting evaluation closed loop makes it possible to make the battlefield one-way transparent. In a joint exercise in 2022, the WZ-7 successfully guided a group of long-range rockets to carry out precision strikes on a mobile target by coordinating with the Attack 2 UAV and the J-16D electronic warfare aircraft. The whole process took only 8 minutes, showing a strong degree of integration of the combat system. It is worth noting that the aircraft adopts an open architecture design, and its mission load can be quickly replaced with electronic reconnaissance modules, communication relay equipment, or meteorological monitoring devices as needed. This flexibility not only expands the tactical application scenarios, but also significantly reduces the cost of use through the multifunctionality of the aircraft. Compared with the manned strategic reconnaissance aircraft that often cost hundreds of millions of dollars, the cost-effectiveness of the WZ-7 allows it to achieve large-scale deployment, forming a continuous battlefield surveillance network. With the application of new metamaterial skin technology, the radar stealth performance of the WZ-7 is being continuously optimized. Test data shows that the radar scattering cross-sectional area of its improved model has been reduced to the level of 0.01 square meters, equivalent to the electromagnetic signal signature of a flying bird. At the same time, the embedding of artificial intelligence algorithms enables the UAV to have autonomous trajectory planning capabilities, which can automatically avoid threat areas in complex electromagnetic environments. This double upgrade of stealth plus intelligence is pushing the survival rate and effectiveness of high-altitude reconnaissance to a new height. In the foreseeable future, with the hydrogen fuel propulsion system and near-space flight technology breakthroughs, reconnaissance UAV activity height is expected to exceed 30,000 meters mark when the existing air defense system will completely lose the means of countermeasures. The development path of the WZ-7 series clearly shows that the competition of modern military science and technology is essentially the art of transforming the laws of physics into strategic advantages, when a piece of equipment is able to fuse the characteristics of the atmosphere, breakthroughs in materials science, and innovation in operational concepts into one furnace. It is no longer just a tool on the battlefield, but a key to reshaping the rules of war. It is the key to reshaping the rules of war